In this video, we're going to talk about trigonometric ratios. There's a couple things you need to know first, though. One of our ratios is called sine, abbreviated as SIN, and theta is the angle. Sine is always equal to the opposite side of the triangle divided by the hypotenuse of the triangle. So sine of theta equals opposite over hypotenuse. And a little shortcut we use to remember that is SOH. There's also cosine, which is abbreviated COS, of the angle, which is theta, and that's equal to the adjacent side of the triangle divided by the hypotenuse. This is abbreviated as CAH. The last function that we have is the tangent function, so that's TAN, with again theta is the angle, and that's equal to the opposite side divided by the adjacent side. And we remember this by using the abbreviation TOA. So we have SO, CA, TOA, and that's the phrase that we can use to remember what these ratios are. S is for sine, O is for opposite, and H is for hypotenuse. So the sine is equal to the opposite over the hypotenuse, which is where we get SO. CA, C is for cosine, A is for adjacent, and H is for hypotenuse, which is what we have right here. Cosine of theta equals adjacent over hypotenuse. And then TOA, T is for tangent, O is for opposite, and A is for adjacent. So we have the tangent of theta equals opposite over adjacent. So again, our phrase is SO, CA, TOA. So we're going to use that thinking to do a couple of these problems. So if we look at number 1 here, we have the tangent of Z. Z is the angle that we are using, so instead of the theta that we talked about, it's Z. So if that's the angle I'm going to use, I'm going to label my triangle with that angle being the starting point. So what's always across from the 90-degree angle is your hypotenuse of the triangle. Since Z is our starting point, what's always across from that is the opposite side, which makes this down here the adjacent side to the angle Z. Well, now we want the tangent of that. If you remember, tangent is TOA, for opposite over adjacent. So from this angle, the opposite side is 21, the adjacent side is 28. So the tangent of Z is 21 over 28, but of course we have to reduce that. So if we divide both of those by 7, that's going to give me 3/4 is the tangent of Z. And that would be our answer. So now we can do the cosine of C over here. C is my angle. Remember, across from the 90-degree angle is always your hypotenuse. Across from the angle itself is the opposite side, which makes this side the adjacent side. It's adjacent to the angle. Well, now since we're looking for the cosine, that is abbreviated CA, for cosine is adjacent over hypotenuse. So the adjacent side to angle C is 16. The hypotenuse is 34. That'd be the cosine of C. Again, we got to reduce this as much as we can. So 16 over 34 reduces to 8 over 17. So the ratio of the cosine of C is 8 over 17. We'll do another one. If we look down here at problem 8, we have sine of C. So C is my angle. So now I have to label this. And this is where it's important to know what the sides are and to remember the definitions. The hypotenuse is always across from the 90-degree angle. Well, here's my 90, so this longest side over here is my hypotenuse. Now my angle is over here, so that means across from my angle is the opposite side. And so then this over here is the adjacent side. Now I want the sine. Well, sine is abbreviated SOH, so that's the SO for opposite over hypotenuse. So the opposite side of this angle is 14, and the hypotenuse is 50. So 14 over 50 is going to be the sine of C. And if you reduce that, that's going to give you 7 over 25 as a sine of angle C. We'll do a couple on the back side. Here it says to find the value of each ratio to the nearest 10,000. Well, again, we have our phrase so, ka, toa. Remember, so is for sine, which is opposite over hypotenuse. Ka is for cosine, which is adjacent over hypotenuse. And toa is for tangent, which is opposite over adjacent. So if I look at these ones here, this first one, we want the cosine of z. So z is my angle, but again, my triangle doesn't look like the normal one that we had. So remember, across from the 90-degree angle is your hypotenuse. Since z is my angle, the opposite side of z here is the 9, and then this side right here is the adjacent side with the 12. Now we want the cosine of that angle. Well, cosine is adjacent over hypotenuse. My adjacent side is 12, and my hypotenuse is 15. Again, I have to reduce that, which reduces to 4/5, which is the cosine of z. We'll do one more. Number 17 down here. We want the sine of z, so z is my angle. Across from my 90-degree angle here is my hypotenuse. Across from the angle z is the opposite side, and adjacent, which means next to, is going to be the 35 right here. Now we want the sine of that, so remember from our phrase so, ka, toa, so is sine, which is opposite over hypotenuse, so the opposite of this angle here is 12, and the hypotenuse is 37, that's the sine of z. So we'll punch that into our calculator. There's 0.324. Or down to direction said the nearest 10,000. So that's, if you look at my calculator here, 0.3243. That's the 10,000 spot, and this 2 back here does not round that 3 up, so the 3 stays there. Equals sine of z. But you guys know I like fractions, so I'd rather you just leave it like that. So I want you guys to try the rest of them, and then go down to problem 22 here. To do these, all you're going to do is punch them in your calculator. So example on 19 here, my sine button is located right here. First I check my mode. I have to go to degree mode. So make sure your calculator is in degree mode there. Now I'll quit that screen, and again, here are my trig functions. Sine, cosine, and tangent. Well, 19 says a sine of 48 degrees. So all I'm going to do is push the sine button, 48 degrees, and hit enter. It's 0.7431. So this is 0.7431. So you guys do the rest of the problem, and don't do the critical thinking at all.